Alright, let's look at the practice exam 3, problem number 2. Alright, for the function f of x here, we want to find the interval where f is concave down. Right, so we need to find the second derivative. So let's do that. Right, first derivative first. F prime of x is equal to, right, so if you have a natural log, right, and here, if you have a natural log of g of x, then if you take the derivative of this guy, what you get is whatever inside the natural log, and write it as the denominator, and the chain rule multiplied by derivative of the inside function. Alright, so in this case, you have a 3x squared plus 1. Then take the derivative of that, put it on top, so you have a 6x. Right? So that's the first derivative. Right, so let's take the another derivative. So f double prime of x. Alright, so 6 is just a constant multiple, so I'll just put that outside. Right, then we have to use the quotient rule. So that would be denominator squared, so 3x squared plus 1, the quantity squared, right? And the derivative of top is 1 times the bottom guy, so it's a 3x squared plus 1 minus, right, top guy is x times derivative of the bottom guys, again it's 6x. Alright, then we just need to clean up a little bit, so this is going to be equal to, alright, let's see, so 6 is already there, so I'm just going to put 6 there. Alright, so you have 3x squared minus 6x squared, so it's going to be negative 3x squared, and we have 1 there, so it's a 1 minus 3x squared. Right? Then the denominator stays the same. Right? So I'm going to set this guy equal to 0. Right, so which gives us, let's see, we can just make sure to make the numerator equal to 0. 6 is gone, so you just set 1 minus 3x squared equals 0. Alright, then we can see that we can just add, actually maybe I'm going to subtract 1 from both sides. You have negative 3x squared is equal to negative 1. Alright, then divide through by negative 3 to get x squared is equal to 1 over 3. Alright, then we can just take the square root of both sides, and I'm gonna go here. Right, take the square root of both sides, so you get x is equal to plus or minus, right, square root of 1/3. Right, make sure to put the plus or minus. Alright, so we can do a number line here. So draw a number line. And use those two values, negative square root of 1/3 and the positive square root of 1/3, and put tick marks there. Then we're going to just look at the sign of the second derivative. Alright, so we can try any sample number less than negative square root of 1/3. I'll probably try like negative 1 or something like that. Alright, so if you put negative 1 into, say, this guy right here, right, negative 1 minus 3 negative 1 squared, so it's negative 2 on top, so that's negative. And actually I forgot the square there. Alright, so that's positive, so positive, this is going to be negative, and this is going to be positive, so the whole thing will be negative there. Alright, then we can try x equals 0 for this interval. Right, if you plug in 0, so that's positive, everyone's positive, so you have a positive here. Right, then we can try x equals 1. Again, that's going to make that negative, so it's going to be negative. So we know that the f is concave down on this interval right here. Right, and that interval there. Right, so therefore, the interval we are looking for would be from negative infinity to negative square root of 1/3, and also square root of 1/3 to positive infinity. Right, so that's the interval where f is concave down. Alright, then let's look for an inflection point, and you can see that the inflection point happens right here at negative square root of 1/3, and at this point positive square root of 1/3, because the second derivative changes its sign, which means that the original function f changes its concavity. Alright, so we just need to find the f corresponding y value. So I'm going to plug in a negative square root of 1/3. Then you will see that you're going to get natural log of. Alright, so it's square root of 1/3 square would be 1/3 times 3 is 1 plus 1. So it's actually natural log of 2. I'm going to just write that, natural log of 2. And since it gets squared, if you do a positive 1, negative 1, still get the natural log of 2. So that's the corresponding y value for both of them. So therefore, if you're looking for inflection points, so inflection points, and that would be, and the first one would be negative square root of 1/3, comma, natural log of 2, and the positive one. Can I do this? So plus or minus natural log of 2. So there are two inflection points. Alright, that's it. I hope that this was clear.